Another problem. If you buy a 3-scoop ice cream cone with vanilla, chocolate, and strawberry as possible flavors, how many different cones are possible if your cone has only 2 of the flavors? Flavors can be repeated or not, and 2 cones are considered to be different if the flavors occur, but in a different order. Okay, let's look at this in the same way we've looked at them before. I'm going to omit the tree diagram solution because it's so straightforward. I think you can follow through that no problem yourself. And what you're doing there is you're doing all the branches where no branch can have all 3 flavors, because it says a cone has only 2 flavors. But also it must have 2, so you'd eliminate any branch that only had 1 flavor. But I'm going to instead use the fundamental counting principle, leaving the tree diagram to you. So I'm going to go straight to the fundamental counting principle, breaking it up into subtasks, counting the number of ways each subtask can be done, and then multiplying. And what I'm going to do is say, well, I need to figure out how many ways to choose the first flavor, how many ways to choose the second flavor, and how many ways to choose the third flavor. Multiply those together, I'm done. First of all, it's obvious that I can choose any of the 3 flavors, either vanilla, chocolate, or strawberry, in the beginning. No problem with that at all. But I can also choose any of the 3 flavors for the second flavor either, because my only conditions are they can't all 3 be the same flavor, so it's okay for 2 of them to be the same, and I want the cone to have 2 flavors, so some flavor is going to have to get repeated because I can't have 3 different flavors. So it's perfectly okay to choose any of the 3 for the first choice, and since I can repeat a flavor once, it's perfectly okay for the second flavor to be any of the 3. It's the third flavor that you have to be careful. Now, think about this. We're not allowed to have 3 of the same flavor, and we're also not allowed to have 1 of each flavor. So no matter what, the third flavor can only be chosen from among the 2 of the 3 available flavors. In other words, if you've already gotten 2 of the same flavor, like you started off with 2 chocolates, then you could either choose vanilla or strawberry. You'd have 2 choices. If they're 2 different flavors, say the first one was chocolate and the second one was vanilla, then you still got 2 choices. You can either match the chocolate or match the vanilla. You can't choose the strawberry because that would give 3 different flavors, which is also not allowed. So either way you go, there's only 2 ways to choose that third flavor once you've chosen the first 2 flavors. If you're having trouble grasping that, actually draw off the tree diagram. So you've got 3 choices for the first flavor. Because you can duplicate a flavor, you can pick anything for the second flavor. But for the third flavor, you're either going to, if the flavors are different, you have to pick one of the 2 that haven't been chosen yet. And if the flavors are the same, you have to pick one of the 2 flavors that don't match the 2 that are the same. In either case, there are 2 ways to do that. So 3 times 3 times 2 is 18. So there are 18 different cones that satisfy those conditions.